This is my presentation on the piano tone project I did as BMP43 with AG3492. The aim of our project was to make a middle C note we recorded on the piano sound good by removing noise through a filter. So to complete this project, we recorded a signal of the note played on the piano. We then ran a script to see which frequency component was the greatest, so we could find the frequency of the notes. And then we'll run a Python script to create a filter to remove the noise. So the FFT was very crucial to this project, and what it does is it plots a graph on the frequency axis instead of time axis. You can think of it as a song, and instead of having a graph or a wave of the song with the length of the duration on the axis, instead it shows each note is on the x-axis, and the y-axis is how loud each note is. So the fast Fourier transform is a specific algorithm used to speed up Fourier calculations. And then from the plot of frequency against amplitude, we were able to find which frequency we needed to filter around for our piano. So to remove noise, we wanted to reduce the frequencies that are far away from the 260.5 hertz we found out from the last slide. So to do this, we would calculate coefficients and multiply frequency components by the coefficients. And you can think of this like slats on a blind, where to calculate sort of how much light gets through or how much of a frequency gets through, through using coefficients, we can adjust the angle of the slat or the blind. So ideally, a filter will be able to block off all the unwanted frequencies. However, this will lead to a sharp transition in our frequency plots. And when we inverse Fourier transform that and put it in a time domain, which is what we want our output to be, we'll get lots of noise and almost clicking sounds if we were to play the filter signal. So as a result, we applied a Hanning window to our plot, which will taper our output frequencies to result in a more natural signal. Our final results show the noisy signals on top being filtered down below to a nice, clean, one frequency signal. Thank you for listening.